Hi everyone, today I want to present a concrete solution named self-healing concrete which can hopefully benefit the whole world. For several years, concrete has been widely used in construction industry. Nowadays, what plays a significant role in concrete technology is its material's durability under different conditions. This feature could be threatened by different physical and chemical attacks. What causes most of concrete deterioration is the existence of cracks and microcracks, which will make the whole structure vulnerable because they facilitate the seepage of water and other chemical agents that will result in steel reinforcement corrosion and eventually a considerable reduction in concrete's lifespan. Self-healing concrete is mostly defined as the ability of the concrete structures to repair their small cracks autonomously. Considering concrete as a live material seems more compelling from the durability point of view because concrete shows different characteristics under different circumstances during its lifespan. The importance of this subject will become more and more obvious as we see the consequences of neglecting the long-term behavior of concrete. On the other hand, if we rely on cementitious or polymer-modified repair mortars, a huge amount of budget and attention should be dedicated to the repairing layer and its connection to the base layer, while paying attention to the durability considerations in a concrete mix design and sufficient curing could minimize the cracks in concrete. Cracking is an unavoidable process in every concrete structure. Using self-healing agents in concrete helps this material to heal its crack as an active mechanism without any external procedures, so concrete lifespan will increase significantly. There are different available solutions to the problem of how we can provide the self-healing process in concrete. According to the Hank Yonkers, bacteria could be used as self-healing agent in concrete if they meet the following 6 requirements. Some kind of bacteria, if able to resist in a concrete harsh environment and have a sufficient food supply, can produce spores which will reduce concrete's permeability. They should be incorporated in concrete while acting autonomously. These self-healing agents should not affect other concrete characteristics negatively. Using bacteria in lightweight aggregates such as scoria shows no or negligible harmful impacts on mechanical properties of concrete such as compressive strength, stiffness, and ductility. Adding bacteria directly to the concrete results in their short lifetime, while adding them in some polymeric microcapsules can increase this time significantly. These healing agents should work as a catalyst so they would enable multiple healing events. Using bacteria will increase the concrete's construction cost notably. However, if we consider life cycle assessment analysis, and if these bacteria do increase concrete's durability, using them makes economic sense. Considering all of these requirements, what has been suggested is the use of two-component self-healing agents including bacillus bacteria and calcium lactate as food supply, both embedded in lightweight aggregates. These agents will commence activating by the ingress of water that happens due to the cracking. Then subsequent calcium carbonate formation results in the closure of microcracks up to 0.46 millimeters after 100 days, which is approximately 2.5 times greater than the closure in OPC concrete. Also, consuming oxygen by bacteria dwindles the probability of steel reinforcement corrosion. Tellerier et al. Proposed a new self-healing agent that involves sodium silicate solution stored in polyurethane microcapsules. As cracking reaches the surface of these microcapsules, sodium silicate releases and reacts with calcium hydroxide in cement, and as a result, CSH is formed and heals the crack. Their experiments demonstrate that using this agent causes an increase in ductility, stiffness, corrosion inhibition, and no negative influence on compressive strength. Shape memory polymer is known because of its ability to respond to external impetuses by changing its physical shape. Firstly, SMP fibers are embedded in structures while they are knotted at both ends to create a mechanical anchor. Then, after casting concrete, these polymers are deformed. This is called temporary shape. This shape will remain stable unless they are thermally activated, which triggers the recovery of the original shape. Then, if the two knots lie on either side of the crack, the development of shrinkage stresses applies compression on the crack faces, which results in crack closure. It should be noted that if we have a good estimation of probable cracking patterns, these fibers are placed where they can close more cracks and therefore works more efficiently. Using this approach properly prove a better increase in stiffness and ductility compared to other self-healing approaches. The application of self-healing concrete in the construction industry as a new challenge can cause a great upheaval. The promotion of self-healing technology in concrete field has been restricted mostly to laboratory experiments due to the challenges like the availability of self-healing agents, influence on concrete's mechanical properties, and being cost-effective. But considering the characteristics of suggested self-healing agents, why shouldn't we start using them for larger projects? So our solution is a wider application of self-healing concrete in construction. Fortunately, there are some recent full-scale projects which have been using this technology successfully. To investigate the influence of using self-healing concrete in a hydraulic service environment, a bacteria-based agent was mainly used in channel walls on both sides of the log chamber in Magneto. Moreover, some concrete samples were cast to check the effect of self-healing agent addition on compressive strength and crack closure. The results showed that by adding self-healing agents, no significant effects on the performance of the concrete mixture and the development of compressive strength will be observed. Field observation also shows that cracking was healed after 60 days and leakage was successfully blocked. At the end, I want to thank you all for your attention.